This video is over section 2.6 and goes over a problem that involves sine functions. Alright, so this is number 43 in your book, and it actually has a couple of different sine functions going on. So let's go ahead and go through it. Alright, so it gives us the limit as x approaches 0 of that whole big mess there. Okay, so remember when we have these types of problems and we're solving limits algebraically, our first step that we always want to do is to try direct substitution, see what happens. Alright, so I try direct substitution. I plug in 0 wherever I see an x. On the top, I get sine times 3 times 0, or sine of 3 times 0, which is just sine of 0. Remember, sine of 0 is just 0. Times sine of 0 again, 0. Over on the bottom, I'll get 0 times sine of 0, also 0. I have 0 over 0. That's an indeterminate form. That means do more work. And remember, when I'm working with trig functions, my do more work, the simplifying that I want to do, is I want to first make sure that my function is rewritten in terms of sine and cosine. And then second, I want to make it try to match an identity. Now in this problem, we only have sine functions, so we're only worried about the sine identity. And remember, that tells us that the limit as x approaches 0 of sine x over x equals 1. But remember, this x, it doesn't have to just be x. It could be sine anything over that same anything, and the identity works. That limit is just 1. All right, so for this type of problem, I'm going to separate it out into different fractions, so hopefully it's a little bit easier to see what we need to do in order to get this function to match this identity. All right, so I have the sine limit as x approaches 0 of sine 3x, I'm going to keep that over x, times sine 2x over 1 times 1 over sine 5x. All right, so I just split up my function, wrote it like this. Now I'm going to multiply it by something so that each of these sections matches this identity. So remember, my identity is sine something over that same something equals 1. So at this first fraction, I have sine 3x over x. Well, what am I missing here? This something doesn't match this something. So I need to multiply it by a number so that they do match. In this case, I'm going to multiply it by 3 over 3. So that way, when I bring the 3 over, I'll have sine 3x over 3x. It matches the identity now. Same thing for the next fraction. I have sine 2x over 1. What's missing here? Well, I need a 2x on the bottom. So for this part, I'm going to multiply by 2x over 2x. And now going to the third fraction, I have 1 over sine 5x. What's missing here? Well, I need a 5x on the top. Even though this fraction is flipped over and it's inverted, the rule still works the same way. So for this third fraction, I'm going to multiply by 5x over 5x. All right, from here, I'm just going to rearrange some things so it's easier to see how each of these parts matches our identity. So this first fraction here, I'm going to bring the 3 over. So now I have sine of 3x over 3x times, remember, I still have a 3 in the denominator here. So I'm just going to write that right here so we don't forget about it. Okay, now for my second fraction, I have sine of 2x over 1. I'm going to bring my 2x over. I have sine 2x over 2x. But remember, I still have a 2x here in the numerator. So I'm going to write that there so we keep track of it. And now for this third fraction here, I'm going to bring my 5x over. So I have 5x over sine 5x times, now I have a 5x left over in the denominator. Okay, from here, hopefully it's easier to see how each of these parts matches our identity. And remember, this whole problem is asking us for the limit as x approaches 0 of this function here. We just rewrote it a little bit. Now, wherever we have a fraction that matches our identity, I can just cross that out and put 1. Because remember, that's what our identity says. The limit as x approaches 0 of sine something over something equals 1. Okay, so I have sine 3x over 3x. Cross that out. That's just 1. Sine 2x over 2x. That's 1. 5x over sine 5x. Remember, it works the same way, even though it's flipped. That's just 1. And now I'm just going to see what I'm left over with. So I have the limit as x approaches 0 of, I have a 3 here, times my 2x, times a 1 over 5x. All right, multiply that out. 3 times 2x gives me 6x over 5x. My x's can cancel, and now I'm just left with 6 over 5. And remember how in our first step when we tried direct substitution, we got 0 over 0 in an indeterminate form? Well, when we rewrote the function a little bit, simplified it out, my answer ended up being just 6 over 5, which is a valid answer, which means that we are done. This is the answer to this problem. The limit as x approaches 0 of that really huge function that we started with is just 6 over 5. And that's the end to this problem. Now, just brief recap. I had this huge function here. My first step, direct substitution, led me to an indeterminate form. So from there, I wanted to first make sure that the entire function is written in terms of sine and cosine, which it already is. And then from there, make each sine function match the identity. And I did that by multiplying each fraction by a term. That would leave me with sine something over that same something. From there, each fraction that matched the identity, I just crossed out because it equals 1. And then from there, I multiplied everything out and got my answer, 6 over 5.